Today we're going to build the MeArm version 3. We're going to build the Arduino compatible version. The MeArm build is the same with all versions. First thing we're going to do is take them out of the box. Here we have a pack of screws, a ribbon cable, the base board, our Arduino compatible board, 2 thumbsticks. Place this carefully down, 4 Metal Gear servos, and the acrylic parts pack. First thing we're going to do is we're going to put the thumbsticks onto the baseboard, connect that with the ribbon cable, power it up and attach our servos to calibrate them so they're in the correct position for the finished MeArm. We need to build the MeArm with calibrated servos, otherwise you'll have to come back to that job later on. Now we're going to remove the servo motors from their bags and attach the servo horns once we calibrate the motors. To begin the calibration, take each servo in turn and attach the servos to the baseboard, making sure that the orange or yellow wire on the servo motor is lined up with the Y or O mark on the baseboard. Then we can power the control board via USB or batteries, and this will set the servo motors to their default positions. Now, with reference to the instructions, we can add the servo horns, which are the little black bits in the bags, to the servos to complete the calibration. So we select a servo horn for each servo, and we need 3 the same, which are a single servo horn, and a single double servo horn, so 4 in total, and we also need 4 of these tiny metal screws to attach them on once they're calibrated. So now, taking each servo in turn, starting with our left servo, we can add a single horn, and we want to reference our instructions for the positions and put it on into the central position, which in this case is facing down to the 6 o'clock position. Now take our gripper servo, and we do this in exactly the same way, where we place the servo horn on to the 6 o'clock position. Next, take our central servo, and for this we use the double horn and place this so it's pointing to 12 and 6. And then finally is our right hand servo, where we place the servo horn on towards the 9 o'clock. If we place a screw in each one to secure them, personally I leave the screws out till I'm actually finished. But what we can do now is we can use the joysticks through our powered board to test the range of each servo. If we try and do this as we go along through the build, we can make sure that our MeArm moves correctly, and so that when we get to the end we won't have a nasty surprise. Now unplug the control board, place our servos to the side for later on. At this point you can also mark the servos to make sure that you have the correct servo for the correct position when it comes to that point in the build. Now we're going to start our build. So let's open our acrylic pack with all of our parts. The MeArm comes in 4 sheets of parts. All the parts you need are there. If there are any holes where there should be a part, please get in touch with support. We can get the part out to you, but they should all be there. Now, one of the things to note is the acrylic has a backing on it. We need to take this off so our MeArm can move smoothly. The first step in building our MeArm is to take the base servo with the double-headed horn and push it through the baseboard. There's a couple of notes on the board which should show you which end to put it, and you want to make sure the pins are upwards and the servo horn is down. So we're taking this first part, which is not numbered, so have a look through the parts. Any part which looks the same is the same, so this part should be fairly obvious. Slots into the board over the servo to hold it in place. Not particularly securely until we get to the next stage, which, if we take our pieces out of the board gently, like so, we can insert them onto the baseboard, front and back. So these parts look very similar and are in fact exactly the same. And you should see that's kind of a theme. Now we take the cable and we wrap it through the central part, which should A, hold it down, and B, make it nice and neat for later on. And just like we did when we calibrated, we place the yellow cable to the Y or O on the baseboard. Now the next part, we take these two L-shaped pieces and these slide through the base pieces we've just put on. They slide through the bottom, hook around the PCB, and the holes in them line up with the edge of the second parts that we used to go on either end. Now you should find this sort of holds together fairly well. So now we take the left side, which is this part, and this just slides on the side. It should be a fairly firm fit. The PCB pushes into the side of it and the pieces we put on earlier fit on. Just push that gently home, and then we should be adding our first screws. Opening our screw bag and tipping them all out. Now you can make a choice here. You can either order them all yourself to make sure that you've got the correct number of everything, or you can just leave them in a pile like I have. So we have an assortment of screws. 2 of them are 16, and then we have 10mm screws and 6mm screws. So they're just the 3 sizes. Here we're going to use 2 10mm screws, first pushing them gently in. And we can use the Allen key to secure them. Now, since you don't want to spend most of the video watching even a speeded up version of me with this Allen key, you can very gently use a nice drill. If you are using a drill, you can use a cut down Allen key in the chuck and then put it onto its lowest torque setting, so that if you hold the end of the drill, the torque setting will cause it to slip in your hand. That way you won't over tighten and break anything if you are using a drill. But then again, I would only recommend a drill for advanced users. Now we add the right hand side, which, just like the left hand side, pushes onto the parts we've already used, onto the PCB, and slots firmly into place. Again, we secure this with 2 10mm screws, which should push easily through the first hole, and then using your Allen key or drill, they'll self-tap into the central part, in fact into those L-shaped pieces that we put in earlier. Next step is to build the central strut. For this we need this piece, and we need these 2 pieces, and we need a third piece, which is one of these that looks like an E. So the way this goes together is we place one piece on the top, another piece on the bottom, hold them together. Can be a little bit fiddly. And then we add the E part in between them, and then push a 10mm screw through, and then we want that to bite into this central E piece to hold it all together. If you tighten it so it just bites in, you can then straighten all the pieces up and then screw it tight. and that should make a nice secure central piece. Continuing to work on our left-hand lever from the central part we've just built, we want to take this long lever part which has 3 holes and line it up and hold it up over the existing piece at the top. Then place a 6mm screw through the hole. It should push through the first part and then should screw into the central part. Holding it together like this and screwing it together will mean the screw will go in straight and will hold the 2 pieces in plane, so you won't have any cross-plane movement. Now we want to make sure with this part that we have a good amount of movement. Again, we don't want to move side to side, but we want it to move nice and loosely like this, as it's a pivot. Next part, we're going to add one of these lever parts. There are 2 of these identical in the pack, but there's also a part that's very similar. The similar part has a triangle laser cut into the length of it. For this part, we'll use the part without a triangle. Again, if we overlay it with as much of the existing piece as we can to make sure that it stays in plane. This will be in line with the existing lever and uses the top lever to attach to. Place a 6mm screw through the top, which should push through our 3-hole lever that we just put on, and then it should screw into this single 2-piece lever that we're just attaching. We're going to add another strut, which is our bottom strut, which will go across the base, which is made out of 2 pieces, which screw together to make a single piece, which join across the bottom. We take one and overlay it, 1 piece, put a 6mm screw through the middle, which will again push through the first and screw it to the bottom. Since the middle part isn't going to be a joint, it can be nice and tight. We use the drill. Then we use a 10mm screw, push this through the back, and it screws into our 2-hole lever that we've just put on. Lay the whole of it over the straight lever so we can cut the thread nice and straight so we don't have any cross movement. Again, you can tighten that up. Of course, with any of these pieces, if you over tighten them, you can just give them a little half turn to loosen up, and this will just lay over this front part. There'll be a screw in that bottom part. For now, we'll build the rest of the lever. We'll add this piece we saw earlier on to the other side, which is the right part. It has a large cutout at the bottom. Apart from that, it looks very similar to the left piece. This E piece, like we saw earlier on, slots into the middle. 10mm screw goes through, and then we can just tighten that up, and it secures this right part of the central strut together. The next pieces we need are this piece, this large triangular piece with 3 holes and a small triangle cut out of it. This piece, which is another of the central levers, it has a slightly circular end. The central lever that's identical to the one we just used. We place this piece on first, the triangular piece on top. We can place a 10mm screw straight through these 2 pieces and screw it onto the top of the right hand part of the lever that we've just added. If you're using a drill, watch out because these things spin. So if we notice here, I screwed this a little bit too tight, but the self-tapping is quite secure, so we can just unscrew that, just a half turn, and make sure we've got a nice bit of movement there. Using the second lever, we attach to the back, using a 6mm screw, which pushes straight through this top part, and then attaches to the back. I'm going to use the drill again. Now finally on this part, we use this piece with a triangle, and now you'll notice handily there's a triangle in the triangular part we've just added. those two line up close together. It's actually easier if you hold it across the back of the piece, and then just using another 6mm screw straight through, and you can see it spin as I And again, this is going to be a pivot part, so we don't want it to be too tight. We don't want too much cross movement. You see there's a little bit of cross movement here, but we can change that later. Next we connect this to the piece we built earlier, to the central lever that we've just built, or the giant octopus thing, as we call it. The best way to do this is from the left side. We add a 6mm screw. We place it into our central lever. I place it onto that hole, which then our base lever sits into that. You can line that up. If you see through the side, there's a screw hole in the central piece. So now we attach this to the central piece. We can put the screw through the hole on the central piece with them lined up. Use an Allen key just to gently tighten it so it starts to bite into that hole on the central piece. And that's the first stage of attaching these two parts together. You see it's still quite free and loose here. As we add more connections, that will improve. You don't have to go very tight right now. Now we attach the lever on the back of the triangular part to the back of the right hand panel by using one of these small spacers. Push the 10mm screw through the right hand panel, through the spacer, and screw it into the lever that we've just talked about. Be careful here, because sometimes the end of the screws can get quite hot as they cut their way through the acrylic. Now we're ready for the next stage, where we add another servo motor. So we take a collar and our left-hand servo motor, the one where the servo horn is in the 6 o'clock position. We take the wire from the servo motor and we thread it through the collar. Then pull the cable through and seat the servo so it's flat to the back of the servo collar. Now we push this assembly through the hole on the left panel of the MeArm, and we push the servo horn into the servo horn shaped hole on the bottom lever that we made earlier. Once that's on, we use two 10mm screws and push them through the servo collar and screw them into the left-hand panel of the MeArm. Once screwed in, if we want to keep the cables nice and tidy, we can wrap this tightly around the servo 3 times like so. Then it just tucks in behind the servo collar and plugs into the baseboard as we looked at earlier, so that the orange or yellow wire goes to the pin marked with a Y or an O. Now we repeat this on the right hand side, making sure to use the correct servo motor, which we set earlier, for the right hand side, which is set in the 9 o'clock position. So now to build the claw, we take the collar part for the claw. This is important to get the right way round. So we insert the servo from the bottom and bring it through so that the cable goes through and the servo motor ends up looking like this. The next two pieces we use are these side parts, and these will slot into our collar piece, and they slot in either side of the servo. This one goes across this side, and this one just slots in like so. And if you leave it sitting this way, which is actually upside down, and find this next part. Now this next part seems counterintuitive because you actually have to slot it over, not in its final angle, but slot it over so that the registration mark goes over the servo horn, and then it rotates the whole way around there, and we hold that into place. And we secure this using our two 16mm screws to hold it all together. Now we take our two claw pieces, which should be obvious, there aren't many pieces left, and these ones look like claws. One pushes over the servo motor horn just like this, and the other one sits the other side, but we need this piece to hold them together. Place this part over the top and take a 10mm screw. Should push through the top piece and straight through the claw, and then secure into the base panel with a little bit of Allen key or screw tension. Now just test that these move correctly. Here the base panel may be a little loose or a little tight, and you can adjust that as needed. The bottom part should be fairly solid in that it doesn't move up and down very much, but the claws should be free to move. Now we just need to attach the claw to our main part of the body, which we made earlier. We have one hole on one side and two holes on the other, which should match up to our levers, unless you've got a left-handed head, in which case you either need to rebuild your body or rebuild your head. Place a 6mm screw through the appropriate lever, screw it onto the claw, and then flip it over and take two 6mm screws and do the same to the other side. Once we've added these three screws, let's just check everything and make sure that the MeArm moves nicely, and we can either tighten or loosen the screws as necessary, and then we just thread the cable through before we start our final assembly. This threads through the central lever and plugs in just at the front of the MeArm, remembering to keep the yellow or orange to the Y or O mark on the circuit board. For the final stage, we just need to add the MeArm to its base. First of all, we take this piece here, which slides over our base, and then this final large part slots over and registers onto the servo horn. Add two 6mm screws through here, and then all that remains is to add 4 sticky feet, one in each corner, and your MeArm build is complete.